Okay, so hi everyone. So it's time for the lightning talks. Yay! Okay, so all the speakers of this session, so please come to the front and sit down in the first 2 rows of these seats. So speakers, please come to the front. All right? Okay, so the number of lightning talks has been increasing. Yay! So actually, so it's overflown, so please keep the hard limit. And here is one new rule in this BlinkOn. So this time, so I asked all speakers to insert one point where they can get a storm of applause. So when you find that point, so please give a round of applause, okay? Yay! Okay. Okay, so the first speaker is Antonio. So please come in.
So do you have the slides? So, hello everyone. My name is Antonio. I'm going to be showing, you're not seeing, I guess. So it's not projecting? There we go. So, I'm going to be showing very quickly a project that we are running. Okay, it's gone again. So, yeah, it's Chromium on Wayland. It especially matters for users of Linux. So basically, I'm from Igalia. We are everywhere in the globe. The goal is to be able to run Chromium natively on Wayland without the user to notice that it's actually a new Chromium version without any performance loss against stock Chrome. So there's various people using Wayland today, automotive, mobile, desktop. So it's getting some momentum. I just prepared a quick demo because I cannot use my laptop to show it for running. So basically what you're going to see here is the same Chrome that you guys are used to use on Linux on X11. So if the end user notice zero difference against our contribution, then it's our success. So what shows here is nothing new, but there is one thing that is new that we are trying to do is that the same binary that we are running Wayland, we also run on X11 as well. So on the right over here, that's loading, it's Chrome X11 from the same binary that we're running Chrome Wayland. So that's the applause spot, so please applause. We've done various things already upstream, but it's not finished yet. So here's some stuff that are upstream already. So XCG support, keyboard, and the rest of the stuff, they're already downstream and they're on its way making upstream. There is also a design doc for others that are curious about the solution. These are some ongoing stuff that are not upstream and are not downstream yet. We are working on them, like the wide GPU split, that's important. Dialogues, because they do not have GDK available, so we have to come up with dialogue somehow. Drag and drop, mood screen, and other stuff. We're planning to make DAP and RPM packages available. We're going to continue to upstream things, and we have build bots running various tests. So we have everything in place, I guess. So thank you very much. This is my contact. Thank you.
Thank you very much. So the next speaker is Gyuyoung.
Hello, everyone. My name is Gyuyoung Kim. In these talks, I would like to introduce the state of the registerProtocolHandlers. Okay, first, let me introduce what is the registerProtocolHandlers. The picture is to give the power to add your customized scheme to your website or web application. If you register your own custom scheme, it can help you to avoid collision with other DNS or help other people to use it correctly. This is the ideas. The idea simply defines the two functions. One is a registerProtocolHandlers, the other one is unregisterProtocolHandlers. Okay, let's check how does Chromium support this feature. This is just simple examples. So in this example, I register the custom GitHub handlers like this. If Chromium meet the register protocol handlers, the Chromium will show a button in the Omnibox. If you click the buttons, the button shows a pop-up to ask if the users allowed to register the custom scheme or not. If user allow these schemes, so this handler will be registered. We can find this custom register in the handler menu in settings like this. And now we can use the registered custom handlers. In this example, the web plus GitHub colon Gyuyoung is we can go the register URL with the given the arguments. Okay, let's check how many users have used this. Frankly speaking, I guess that a few people have been using this feature, but recently I searched how many users use this feature in the ChromiumSets.com. Fortunately, this feature usage ratio exceeds the 0.01. So I think that this feature can live in Chromium longer. Okay, and in this slide, I would like to check what problem was fixed recently. So I have many fixed bug and add a new test case for existing implementation, and I sync with the latest W3 specification. So I would like to take this talk to thanks to all reviewers who reviewed my CR, including the Cantors. And what's next? I think the continue following these features, following the latest W3 specification, and then I think that we need to check how to handle security issues. As known as in the world, there are some security issues on these features, hijacking, register spamming, and misleading title, and so on. So I think my plan to add a new test case to check these security issues. And lastly, there was a easy protocol handler registered in the W specification, but it was dropped from the HM5.2 specification because no browser supported this feature. So, but it seems to me that this function can be needed to the users. Okay. Okay. Thank you. Thank you so much.
Thank you very much. So the next speaker is Alexey.
Hello, my name is Alexey. I'm working on Chrome DevTools team, and my main focus is JavaScript debugger. Recently, half a year ago, VA team introduced side effect-free evaluation for JavaScript, and it was based on static checks of function bytecode before calling any function. And as soon as we can detect any store operation or calling any functions that may produce side effect, we just terminate execution right now. But like in this example, this function is some kind of poor, and it doesn't produce any observable side effect outside of its own closure. So it looks like for this function we produce false negative when we mark it as side effect non-free function. So we can actually take a look at this function and see that array literal here is temporary, and we can create this literal easily. We can call delete on temporary created set because the set is not leaked from this function and code outside cannot detect change of the set. And we can actually create temporary iterator to implement spread operator and call this as well. So we need, instead of static checks, we need to introduce some kind of runtime checks. And first part is we need to mark temporary objects during function call. And to do it, we can just reuse existing allocation profiler. And for any objects that are allocated during current evaluation, mark it as temporary. And we may instrument code of function and inject some hook before calling any store or calling any non-side effect-free function. And to do it, we can just reuse existing patching mechanisms that we use for breakpoints in V8. So by just reusing two existing primitives in V8, we can introduce runtime checks and marking temporary objects. And so now we can run much more functions, and we can run this function with run this function and guarantee that this function doesn't produce any side effects. So based on this primitive, we can build nice debugging tools later. And it's point for applause. We can run this function without side effects. And so big thanks. If you have any ideas how we can build something cool in DevTools based on it, you're welcome, and please share them.
Thank you very much. So the next speaker is Yang.
Yeah.
5 minutes, right? Okay, so my name is Yang. I lead the V8 web tooling team in Munich. We focus on making V8 great for embedders, for JavaScript developers, and V8 developers. So today I want to show a couple of things we have been working on since the last BlinkOn. So one thing we've been implementing is setting breakpoints in built-in functions. Built-in functions are the ones that are not backed by JavaScript source. So built-ins defining JavaScript, for example, or DOM methods. And this is some feature that people have been wanting for almost 10 years. Essentially, ever since V8 went open source. And now we have it. So the way this works is that, let's play the video. The way it works is that you open DevTools console, you use the debug function to set a breakpoint on built-in, and you can use undebug to remove the breakpoint. You can use monitor to log invocations of the function, and unmonitor to remove the logging. And also what you can do is to use conditional breakpoints. And in this case, you can use this for a receiver and the arguments object for incoming arguments. Yeah. So one thing that's actually pretty fun to see is another video. So in here, I monitor site timeout and scroll on the mobile app of Twitter, and you can see all of the invocations of set timeout with the function callback that's scheduled. Okay, next thing. We also have been investing a lot of time in making sure that async await and promises are fast. The reason to do so is that so async await and promise allow some pretty cool usage patterns since they were introduced in JavaScript, but to make sure that people actually use them and do not worry about performance, well, we have to make them fast. And so here are some of the benchmarks we have been running. So both for transpiled code and for native code, we have been making a lot of progress. So you see a V8 5.5, that's 1.5 years ago, compared to what we have now, we are way faster. And the way we did this are a bunch of different tricks that we have been employing to basically make features faster. We introduce fast paths. We make sure that certain things that are on the hot path are optimized. We make sure that the objects are not unnecessarily large. And in some cases, we inline certain things into optimized code. Last thing I want to talk about is the heap memory reduction that we have been working on. So for those of you who are not familiar with what a V8 isolate is, a V8 isolate is essentially an instance of V8. Every renderer has at least one. Every worker has one. The proxy resolver runs on its own isolate, and every isolate has its own JavaScript heap. The isolate is not particularly cheap. So to create a new isolate, what you need is at least 1.5 megabytes on a 64-bit platform. And of those 1.5 megabytes, we have around 1.2 megabytes of code objects. And it turned out that of those 1.2 megabytes, 300 kilobytes are JavaScript built-ins. 300 kilobytes are what we call bytecode handlers to implement the bytecode interpreter. And it turned out that most websites actually only use a fraction of those code objects. So we thought, well, why do we need to deserialize all of them at once? And so we implemented lazy deserialization, which on average saves around 500 kilobyte per isolate. And there's quite some more to come. So currently, code objects are linked to the isolate. They embed addresses that are isolate specific. But if we made those code objects isolate independent, then we can actually share them between isolates and embed them into the binary, which would eventually save more than 1 megabyte per isolate.
Okay, thank you very much. So the next speaker is Michael.
Okay, hey, I'm Michael. I'm working on V8 bindings and more recently Allpen. And this is not something that has shipped, so it's only going to get worse from here on. So it's about stack maps, not real maps. It's more about memory and garbage collection, and more precisely about how to find roots on the native execution stack. There are actually two mechanisms you can use for doing that. The one is where you actually know which stack slot points to an object, and the other one is a mechanism where you don't know that, and you essentially have to inspect each stack slot, and you have to check whether this stack slot points to an object, or it is a number, or whether it's just garbage that's lying around there. Mechanisms are called precise and conservative stack scanning, and the examples there are Orinoco in V8 and Allpen in Blink. So I want to talk about the disadvantages of a conservative stack scanning, which are mainly that it's a requirement to walk this whole stack. It may also falsely classify doubles or other numbers as pointers. And so this is, from a performance perspective, this is far from ideal because you have to scan the whole thing. And also it prohibits certain garbage collection optimizations that where you optimize certain things away. So precise stack scanning in V8, how does that work, or how we implemented it, is using one indirection called handle. And these handles are maintained in scopes, and they register themselves. And the problem with them is that they are slower, obviously, than just natively operating on the stack. It's also a bit cumbersome because you have to manually annotate pointers with handles, and so that's not an ideal solution. I would propose that we look into Clang, since we dropped other compilers support sort of, and only officially support Clang. We could actually make use of Clang plugins to implement stack maps that have precise stack information, and that should be faster than V8's actually its current mechanism, and it should just allow us to precisely scan a stack. That's it. That's chat. Just check it out. The second one is not part of this thing.
Next one is Uram, but he's not coming, so Michael is speaking on behalf of Uram.
Okay, hey, I'm Ulan. I'm working on V8, and this is joint work with DevTools folks, bindings folks, and actually lots of people. So what are precise heap snapshots about? It's actually about finding memory leaks, and finding memory leaks is actually a hard problem because these leaks often spawn multiple components. For example, they originate in JavaScript, then somehow the retaining path, the path that actually keeps objects alive, crosses the boundary to Blink, then spawns some objects in Blink, and then comes back to V8. So this is a hard problem. And we have DevTools snapshots, which have been precise for V8 for a very long time, but they had the problem of being only approximate for the Blink heap. So it was actually quite hard to find leaks. We've had examples on popular websites where we knew that there were leaks. We actually knew that they were part of some event listener handling, but we still couldn't find them. So that's actually hints to a problem that some tooling is missing there. here is one of those examples. If you look, like, we have an object that's called leak. We know where it hangs off, actually, but what DevTools showed you back then, or is essentially the best approximation we could get to you, which is it did hang off some native context. There was an HTML document involved. Something was done in object grouping, so you couldn't really see the actual retaining path. What did we do? Rapid tracing to the rescue. What actually launched like last year in February was rapid tracing, which was precise tracing through the DOM. We used it for the garbage collector to actually reclaim memory and not use the approximation of object grouping. But we never actually went the full way. So we generalized the visitation of objects, and now we could finally use it also for debugging. With rapid tracing, for debugging, starting from M66, you get a precise retaining path across component boundaries. So if you have a leak, you can actually see where your leak originates, where it crosses the boundary. You can see your DOM elements. In this example, it's body element, HTML element, the document. In future versions, we also merge the documents because they exist on both in both worlds, essentially, in Blink and in JavaScript. So it's a precise retaining path. And as a bonus, you can actually search for detached windows, which are 99% of the times memory leaks. So these are windows that are actually, or iframes, that are not part of the DOM. They're not rendered, but they're still hanging off some JavaScript objects. So if you use a recent version of Chrome, you can just search for detached windows, and you will see most of the iframe leaks, actually. Right, that's it. Thank you.
Thank you very much. So the next speaker is Sathya.
Hey, I'm Sathya. I have a lot of slides, so I'm going to be going through this pretty quickly. I'm going to be talking about all the latest features in V8. First up is async iterators and generators. ES 2017 brought us async functions. This builds on top of that. That lets us for a weight of iterable that has a bunch of promises. Here we iterate over a readable stream. This doesn't work out of the box yet. Readable streams are not async iterable, but there's standardization work going to make this happen. Next up is object rest and spread. Object rest helps with destructuring, where we create a new object called rest with the remaining properties that are not destructured. Similarly, we have object spread, where we copy properties from one object into the object layer we're spreading into. Next is promise finally. Here we have a spinner and then do a fetch, and then depending on whether it is an error or not, we hide the spinner. There's some code duplication, but with finally, we can just have a finally callback at the end. And then we have a bunch of regex features like .all mode, where the dot should match against everything, but it doesn't match against things like a new line. So with the S flag, now it matches against everything. We have look behind assertions. We had look ahead assertions already. This introduces look behind, both positive and negative, where we look for a pattern. We make sure there's a pattern preceding the pattern that we want. We have named capture groups, where we can give a name to the capture group that we're matching against. Unicode property escapes lets you, like this example matches against all the characters in the Greek script. This was, all of these features were part of ES 2018, and V8 and Chrome 64 support all the language features introduced in ES 2018. Apart from this, we also support a bunch of stage 3 features, like this is dynamic import, which lets you lazy load modules on demand. There's import.meta, which gives you metadata about the current URL, the current module, like the URL or the script element. And then we have numeric separators that lets you group digits using underscores. Then we have BigInt, which lets you have arbitrary precision integers in JavaScript. Here, we no longer have to have a variable bound for the catch clause. So this is an optional catch binding. And then we have trim start and trim end, where we, yes, almost done, where we trim white space. match all matches against all, gives an iterator that matches against all the possible combinations. Class fields brings you instance properties, private and public. And these are all the folks that helped. Thanks a lot.
Thank you very much. The next speaker is Sandra.
Hello everyone, my name is Sandra. I'm from Waterloo office, animation and input dev team. Today I'm going to talk about a new feature to be shipped, which is CSS scroll snap. So what is CSS scroll snap? This is part of my Facebook page, and it's advertisements. I'm not driving a Lexus. So whether it's for advertisements like this or for friend suggestions, most of us should enjoy scrolling images one by one like this. But how do they make sure that the scrolling would end up at exactly one of the pictures? And yes, they are using JavaScript. Now, for better user experience and better performance, we would like to implement it through a browser-native way, and that is our CSS scroll snap. Let's go over a brief history of the spec. There was a deprecated version, but why? Why do we deprecate that version? If we take a closer look, we will realize that scroll snap points, scroll snap destination, and scroll snap coordinates sounds like the same thing, but actually they're not. In addition to ambiguous naming, it also requires the developers to calculate the snap points themselves, and the calculation may become invalid if the layout changes. And that's why we need a new spec. In this spec, you basically just need to specify the alignment of the images. For example, you align the center, so all the images are center aligned. And then you can let the browsers handle all the rest, including the calculation, layout updates, and animation. Let's take a look at some demos. In this example, the scroller has a scroll snap type as X and mandatory, meaning that it snaps horizontally, and it always stops at the snap position. And for the images, it has a scroll snap align as start, so they always start aligned. And now with changing the scroll snap align to center, the images are center aligned. And now they are unaligned. Thanks. By changing the scroll snap type to Y, we can snap vertically. And by using the keyword proximity, we only snap if the scroll stops at somewhere close to a snap points. Now we're not snapping, but now we'll snap. And by adding the scroll padding to the images, to the scroller, we allow some spaces between the image and the scroller. And by applying the scroll margin only to the Chromium logo, we only add the space between the Chromium and the scroller, but not other logos. Where is Chromium? OK, here it comes. There's space. Here's current implementation status for all the browsers. Chromium and Safari are the only two browsers that's working on the new spec. Firefox and IE have shipped the deprecate spec, but they have a plan to update. As Chromium has implemented most of the basic parts of the features, we plan to ship it in the coming M68. You can try it by enabling the experimental web plan features in the About flags, and here's the link to the latest specs. Thank you.
Thank you very much. The next speaker is Jose.
Okay. Hello, this is Jose Dapena from Igalia, working for LG. So we've been doing some effort over last months to keep GCC build running. So yeah, we have Clang, and it's great. We have great support for the newer standards of C++, asynchronizers and compilers plugins, so it's great. So all official platforms use Clang now. Then right now in the bots, the support it's usually basically all the time using Clang. Okay, but unfortunately for us or for people that there are people that are still using GCC as us. It depends because we may have like restrictions because of the toolchain we are using. So sometimes we are still not ready to move to Clang. Not only GCC, we have problems that we cannot move to use the custom C++, live C++. So when we get close to Chromium master, we get to find that the build breaks unexpectedly. So a sample of things like there are different interpretations of the new C++ standards in GCC or Slang, or subtle differences in glibc or bugs in any of the different components. What we are doing, a couple of things. One is trying to keep running Yocto topoki build of Chromium based on Rocco. So while you have there the settings we are trying, Raspberry Pi 3, we are keeping a Yocto layer with all the settings, trying to keep it running. Around 1 build per week on target. So we are basically building X11 Chromium for this Raspberry Pi 3 target, stable beta and development branches. The Awesome Wayland McCanns, the new one that is developed by Igalia, and the legacy Awesome Wayland that is based on the Intel approach. Yeah, more people are doing aligned work. We want to give thanks to them, especially Rafael from Intel. But yeah, also thanks to all the reviewers involved. So we still keep GCC running. Thanks. Yeah, work sponsored by LG, and that's great to have them involved on this. Thank you.
Thank you very much. The next speaker is Robert.
Hello, everyone. I'm Robert Ma from the Ecosystem Infrastructure team. Today, I'm going to give you some updates on web platform tests. In case you haven't heard of it, this is a W3C coordinated effort to build a cross-platform, cross-browser test suite for the majority of the web. Since last year, Quinten and Jeff has built this importer and exporter. We have made some improvements in terms of stability and latency. Our latency is now down to 12 hours for the importer and within 1 hour for the exporter. Most importantly, we see two-way sync actually helps. It boosts contributions from Chromium to WPT. Our contribution has actually tripled since we introduced import-export. And also we can see other browser vendors are doing it or starting to do it. So this is a good sign for the project. By the way, you might have noticed that we have entered this era of 7-digit Garrett CL number. And guess what? Our importer was lucky enough. Yeah, it's us. So the usage of WPT in Chromium has increased from 20% to 50%. Thank you for using WPT, and thank you for relying on our tool chain. One new feature we introduced this year was the import notification. So we heard from you that CCing owners in import CLs can be spammy sometimes. So this new solution basically allows to have bugs automatically fail to you when there's like new failures introduced by import. This is an example of the import notification in action. The only thing you need to do is to add one single line, WPT notify to your owner's file inside external WPT, and make sure you have a component set up. Then every time during the import, there's whenever there's new failures, you will have a bug CC'd to the all the owners in the owner's file. Our focus for this year will be WPT FYI. We plan to increase the running frequency and then add unstable browsers to the dashboard. We will also introduce a new interop view sometime later this year. Look forward to that. Thank you.
Thank you very much. The next speaker is Tarun.
Hi, I'm Tarun, and I'm going to talk about persistent client hints. So let's say you're a web developer, and you want to serve different content to different users. For example, if the user has a phone which is on a slow connection and has a small screen size, you want to show low-resolution images. Or if the user has a fast connection, you want to show high-resolution images. So how do you do that? So one way to do that is to use JavaScript. So you can use JavaScript to determine what are the capabilities of the client, and the capabilities could include network speed, or the screen resolution, or the memory device RAM size, and so on. But if you use the JavaScript to do this, it's too late to modify the HTML, and more importantly, it incurs a penalty of 1 RTT penalty, which is not good. So here's our new shiny solution, persistent client hints. So how does it work? So when user goes to example.com, and let's say example.com wants to adapt the content based on capabilities, then the server is going to set two response headers. Let's say accept CH, DPR, and ECT. That means that the server is interested in knowing about the device resolution as well as the network quality. So when the browser receives these two headers, it's going to see that this server is interested in these two headers for next 30 days, which is 25920000 seconds. So it's going to persist that preference on the disk. So next time user goes to the same origin, the browser is automatically going to attach these two headers with their values, like what was the resolution of the screen and what was the network quality. And then the server can change the content of the HTML. So for fast users, the server can attach a high resolution image instead of low resolution image. So if you're interested in this, you should try out the demo on bit.ly client hints demo. Thank you.
Thank you very much. So the next speaker is Junho.
Okay. Hi everyone. My name is Junho. I'm working at LG. And last BlinkOn, we shared our plan for spatial navigation in the web. So I'm going to talk about updates on spatial navigation in Blink. First, what is spatial navigation? Spatial navigation is a type of focused navigation. It is enabled by directional input. From last year, we have enhanced the existing navigation algorithm, especially to handle navigable containers such as scrollable element, iframe. We also fixed some bugs, added more test cases, and cleaned up code. Also, Hugo wrote a design document introducing the new algorithm. Let's see a demo video. I prepared two fixed bugs. If we hit down key when focused element is scrolled out, then topmost element will get focused. This behavior is fixed on latest Chromium. Thank you. If an iframe is most closest element in direction and it has no focus over child, we couldn't find other candidates properly. This also fixed on latest Chromium. My colleague Jae Hong and invited expert Florian are working on standard. they are thinking about primitives for spatial navigation. If you have any idea or opinion, please share that at the link. Next plan is in here. That's it. Thank you.
Thank you very much. So the next speaker is Michael.
Hi, I'm Michael. I'm visiting from the Munich office. I work on V8, and I want to talk about a security feature for protecting our code that we have added recently. Since V8 is generating code just in time, we are in a situation where we interleave arbitrary execution of JavaScript with generation and compilation of new code. And that means we unfortunately have memory pages that are both writable and executable at the same time. And that leaves those memory pages kind of unprotected. So any out-of-bounds write in the renderer can immediately be used to either fabricate completely new code or manipulate existing machine code. To fix that, we started protecting our code pages. So that means by default, all our code pages are only executable but no longer writable. And only for short windows of time do we unprotect them and make them writable when either the compiler is generating new code or the garbage collector relocates existing code. We do not interleave these small windows with JavaScript execution anymore, so malicious code can no longer see writable and executable pages. However, there are two remaining issues. One is that since we still change the permission bits, the sandbox for the renderer still allows us to flip the permissions, and we would like to avoid this and forbid this completely. Also, web workers still race, so that means JavaScript in one worker might see an unprotected code page in another worker that is currently compiling. To address those two issues, we want to eventually separate the compilation out into a completely separate process. So the renderer process only has an executable view of code pages, but never sees a writable view ever. And the only writable view is in a completely separate process and in a completely separate address space. And now we could completely forbid page permission flips in the renderer and also solve the worker race by this. Thank you.
Thank you very much. The next speaker is Alex.
Hi, I'm Alex, and I'm going to give you a quick update on site isolation launch plans. So the big announcement is that we will be shipping full site isolation. So this means the site per process flag will become enabled by default. And as you may recall, we've shipped some uses of auto-process iframes for things like extensions and sign-in. And we were actually planning a few more intermediate milestones. But then a few months ago, we had a change of plans. And as you may know, this was due to the Spectre CPU attack announcement. Spectre basically means that user-level programs can read anything in their process. For browsers, this basically places the whole same origin policy at risk, because now your JavaScript can just go and steal cross-site pages and passwords and so on. So this is a really bad problem. But fortunately, site isolation makes for a great defense against this, because it ensures there isn't much to steal in the render process to begin with. So if your corp site is an out-of-process iframe, eval.com can't really read any of its data. So this is why we decided to focus on full site isolation, because it's so important to protect our users and save the world. So as part of Spectre response in M63, we've started encouraging users to opt in to use site isolation. And we've also shipped enterprise policies for both full site isolation and isolating a subset of sensitive sites. We've actually seen a lot of opt-in usage, which has been great. Since then, we've been doing a lot of work to get this ready to be turned on by default, like printing networks with UPIFs, fixed a ton of bugs with input events, done a lot of work to bring down our overheads. DevTools has vastly improved support for UPIFs. Chrome driver now works with UPIFs. Like, too many things to list here, but thank you everyone who helped out here. It's truly a big effort. We've been running dev and canary and beta trials. And actually, as of yesterday, we've started a small trial on M66 stable as well. And if that goes well, we are aiming to ship on desktop full site isolation as soon as M67. A couple of things. A few more things you can expect. So Cypher process will soon become the default on tip of tree, but we will enable it at the Chrome layer to start with. So that means other content embedders are not affected for now, but they can opt in, and in fact, we highly encourage them to do so. And as I mentioned, this will be about desktop for now. We will try to include low memory devices. We know they have a bit more trouble with site isolation in some cases, but we're doing what we can to keep them performant and then include it in this launch. But for Android, that's not included, and we will be looking into that next to see what we can do to make site isolation possible there, despite some additional challenges. Thanks.
Thank you very much. The next speaker is Quinten.
All right, so now we're getting close to the end of the lightning talks, and we have a couple of talks from the Chrome operations team. So this first one is a preview of a future development tool that we can expect to see hopefully in the next, before the next BlinkOn maybe, called Tricium. The background is that static analysis tools like linters and more advanced static analysis tools can be really useful. They can help encourage and enforce good coding conventions, consistent style, and then they can find anti-patterns and potential problems in code. But the question is, how does it integrate into your workflow? If it doesn't run automatically, you might run it sometimes, but not all the time, and so it may not be getting all of the usefulness that you could out of static analysis tools. You can put some checks into pre-submit checks, but pre-submit checks can be noisy and they can't be too slow. So how do we fix this problem? We can run static analysis jobs in the background automatically and put results into code review. Yay. But I'm not sure if that was supposed to be the slide. But so yeah, and then to deal with the noisiness problem, we need to have a feedback loop where we can try and filter out results that appear to be too noisy. There's precedent for this. We do this in Google internally. There's a project called Tricorder, and it appears to work. People like it, and it reduces incidence of problems in the code base. So let's bring it to Chromium. The code name for this is Tricium. It's Tricorder for Chromium. And then this is the mascot for it, drawn by Emma Suderberg. So this is what it looks like. Just robot comments in Garrett. They will have a button that says, please fix or not useful. Yeah. It's right. Yeah. And so you may be wondering, how can you use this? What are the analyzers like? Basically, an analyzer is just any program can be written in whatever language. The existing basic ones are in Go. And we'll read from JSON and file contents or other possible inputs and produce a JSON output, which is a list of comments to put into code review. And that's all.
Thank you very much. The final speaker of this session is Jeff.
Hi, my name is Jeff Carpenter, and I'm also an engineer on the Chrome operations team. And today I'm going to be talking to you about what's new in crbug.com, aka bugs.chromium.org, aka Monorail. That's why there's a Monorail cat on this page. So as I just said, there are 4 new things that I'm going to talk to you about. They're in the works that will help you hopefully get things done better, faster, whatever definition of better you choose on the bug tracker. The first thing is approvals. What are approvals? They're a new concept that is coming to Chromium, and they can be whatever you want them to be. This is an example of like a UX approval for sign-off. You can use them to have like test validation approval, have like gates for like Canary, Dev, Beta, Stable approvals for each step of the way, or getting LGTMs from owners. Yeah, so that's approvals. Next is burn down charts. A lot of people have asked for this. Soon you'll be able to put a query in like you would for an issue list search, but instead of a list of issues, you'll get a historical burn down chart. We took 2 features that originally relied on custom ML pipelines, and we rewrote them in ML Engine, and they're a lot better now. What does this mean for you? You get better component predictions. When you're creating a new issue, it'll suggest components, and those suggestions are quantitatively way better now, thanks to our great engineering resident, Kara. You also will see, hopefully, fewer spam issues. Spam is a big problem on Monorail, and it wastes people's time, and there should be less of it now, hopefully. Also, performance. We've heard you loud and clear. Monorail could be doing better on performance. In Q2, we have 2.5 SWEs, staffed full-time on working on performance, and here's what we're doing. We just landed a change that hasn't gone to production yet that makes all issue detail pages, or not all of them, a lot of them, 30% faster. Other things that we're doing are MySQL connection pooling, minifying all the things, we're adding more Polymer elements, and then whatever else Lighthouse tells us to do. And Chromium, CRBug/Monorail is brought to you by these wonderful humans and others that are not on this page. And if you have any questions or ideas, please email us at infradev@chromium.org. Thank you.
So thank you very much for keeping time on the roadmap approach. So thank you very much. So it's super exciting. So the second lightning talk session is scheduled tomorrow at 3 p.m. So please come and join. So see you tomorrow. Thank you very much.
All right. So before everybody heads out, quick logistics. Be really fast. I know I'm everyone's least favorite speaker. So we have a reception. It's just upstairs, not downstairs. There are light apps and drinks for folks. I think I saw like wine and things like that, but don't quote me if it's just water. I'm sorry. So go there. It begins now, so you're already missing out. I'm sorry for that. And we're going to start kicking you out around 6:45. But of course, you can leave whenever you want. So if you want to leave now, catch a shuttle or anything like that, feel free. But also stick around and have fun. Also, remember, don't lose your badge. That's how you get back in. And it's going to create a lot of headaches for us tomorrow morning, inevitably, when people forget their badges. So please don't forget your badge. We'll pick back up again at 8:30 for breakfast, and then talks start same time, not 8:30, at 10. So feel free to come anytime then, between those, but the spaces are from 8:30. All right, thank you, everybody.